What would a Rolls-Royce engine look like if it had a loose crankshaft? That's right, this is the 6.0L V12 engine in the BMW 760Li, but why do I say it's a Rolls-Royce engine? Because Rolls-Royce itself uses the exact same engine. Or in other words, Rolls-Royce bought this engine from BMW to install on its car. This BMW 760Li came to me with a condition where the engine was abandoned. When starting the engine made a light knocking sound. Of course, when the engine was abandoned, the acceleration would be weak and not smooth. According to history, the engine was waiting for me once not long ago. I conducted a general inspection of this engine to find the cause. There are many tests that you can check the engine before disassembling it. It's very simple. You just need to do a compression test and a lift down test, and you can immediately find it. 4 out of 12 cylinders are weak. In addition, I must have remembered that when the engine was down, I could see that it was covered with a layer of metal. There was a lot of metal inside. This proves that the internal components such as pistons, cylinder heads, engine bearings, and western bearings are having problems. Whatever you say, I'll proceed. Just disassemble the engine, guys. Let me remind you that this is a V12 V-shaped engine. The number 12 means 12 cylinders. The letter V is the letter V. You look at the engine liner and you see the V shape. Each side of the V has 6 cylinders. The 2 sides of the V combined are enough for 12 cylinders. In addition, you can also roughly understand it like this. The V12 engine is similar to 2 inline-6 engines combined together. At present, almost all car manufacturers have stopped producing V12 engines. Only supercar manufacturers still use engines with this configuration, so it is extremely rare. Looking at the engine smoke, it is truly a masterpiece of automotive engineering. But then there will definitely be a lot of people jumping in and saying that every time you start the engine, you lose a bowl of pho. That's right, guys, if you play, you have to accept it. V12 cylinder engine uses a capacity of 6, so it will definitely cost a lot of money. It will cost almost twice as much as a regular BMW engine. Depending on the owner, people will have different views on how they use their cars. So I can't discuss these fuel consumption issues. Let's go back to the disassembly work. At this point, you can see that the technician has covered and exposed the entire cylinder cage and piston. When I'm about to remove the belly of the engine, I can drop the piston out. From there, I can check it accurately with my eyes what's wrong with the engine. It's very clear, my initial diagnosis of the engine's condition is completely consistent. After I removed the piston, as you can see, the condition of the piston skirt is very sticky. This connecting rod lining is all gone. Even 4 out of 12 pistons are completely covered. The lining exemptions, as you can see, are also very surprising when the engine has not been abandoned. I think if I try to run for about 100 to 200 kilometers more, if I try to pedal a little bit at a time, it will probably abandon the engine and sometimes break the engine shaft. In general, the condition is not very optimistic. The technical problem is that to restore this engine, it is still feasible. Up to now, I can completely accurately mechanically process this engine. Take measurements of the cylinder, piston measurements, bearing clearance, oil clearance, etc. Bring them all back to the manufacturer's standards. Of course, spare parts must be replaced. Hopefully, this engine will be revived. As I said, this engine has been restored once before, but maybe for some reason it was not done last time. 12 cylinders, for some reason, only 1 is sealed, the remaining 11 are for zinc. But the zinc cylinder is really covered. The newly sealed cylinder also has problems. I don't understand why. Maybe the size is not standard. So the first step is to measure all the engine parts again. Record its current condition. From there, I have these measured numbers. I just compared them with the standard parameters of the manufacturer. It is not enough to tell the customer to change the oil and repair the car, but also to ask the customer to repaint the entire body. That's right, this is the fate of the BMW 760Li using a 6.0L 12-cylinder engine. This is part 2 of the revival of this BMW. In part 1, I showed you the process of dismantling this engine. Seeing that the B-Class engine is very heavy, B-Class piston, B-Class without roof lining. In part 2, you will see the precise mechanical processing of the roof lining. How to bring all the standards of the roof lining parts to exactly as required by the manufacturer. The first step is to break the old cylinder cage. As you know, this car has 12 cylinders, is quite heavily B-Class, and has been overhauled somewhere. But for some reason, during the previous overhaul, they only installed 1 new cylinder. Leave 11 as they were. Of course, an engine requires synchronization between cylinders. How to coordinate the operation of the cylinders as similar as possible. So I had to remove all 12 cylinder cages, rebuild all 12 of them. The old cylinder cage of this roof lining is made of aluminum seal. It means aluminum, but mixed with a certain proportion of silicon. For this ALU seal technology, I have introduced it several times in previous videos. It has many advantages, and it also has many disadvantages. The biggest drawback is that it is extremely susceptible to Class B as long as there is overheating during operation, or lack of lubricating oil, or simply the owner does not pay attention to maintenance. The aluminum seal cage will have problems. As I mentioned, I will destroy this aluminum seal cage, rebuild all 12 cylinder cages with liver material. Liver material is an extremely traditional material, extremely old, widely used all over the world, and the strange thing is like this, guys. For BMW engines of this generation, around 2005 to 2010, people used ALU seal. But because ALU seal was not successful, then for newer generations, people switched back to using the cage. Up to now, the ALU seal cylinder cage technology has almost been eliminated, but the traditional liver cage is still extremely popular. Back to the mechanical processing process, you can see that I have completed the processing of one side of the roof. Now I just flip the roof of one side to proceed with the mechanical processing. The remaining roofing part, the construction process is similar. So, let's move on to the body and paint system to see the technician paint this car. This car not only overhauls the engine, but also paints the entire body, guys. The paint is the original color, the original glossy black. But it's not just a simple spray of color, it's a whole process of treating the base, making it as flat as possible, then applying the primer, then the color, then the gloss. It's extremely time consuming, guys. This painting part takes more time than the engine assembly part. Because it is like an art, and the paint technician is an artist. Back to the mechanical processing system, now the roof has been transferred to the stage called finishing the cylinder. The new cylinder, after being installed, always leaves a certain amount of excess, about 4 to 5% of 1 mm. This excess amount will be ground away by the grinding roof, as you can see. This cylinder grinding work has two purposes. The first purpose is to bring the cylinder diameter to almost absolute accuracy. The error is plus or minus 0.005 of 1 mm. The second purpose, it will create a fox eye scratch on the cylinder wall. This scratch is extremely important. So these scratches are used to keep a certain layer on the cylinder wall to apply on the piston as well as the segment ring. People even calculate how deep the scratch should be. Too deep is not good, too smooth is not good. It must have a certain roughness, guys. And then, the roof part is considered 100% complete. Now let's move on to the remaining part, that is processing the wheel axe head. This car is a V-roof, V12, so it has two wheel axe heads. Each wheel axe head for 6 cylinders. Processing the wheel axe head is also extremely simple. Reprocess the sub-axe mouth, reprocess each sub-axe, then the last job is to flatten the wheel axe face. Just like the face plate, the wheel axe face must be flat. When it is flat like this, I press it on the roof, it will clamp the wheel axe piece tightly. From there, the hardness of the burning mud can be ensured. The burning mud pressure is very large and very hot. So if the wheel axe surface, the peeling surface is not flat, it will definitely be blown out of the wheel axe. Okay, part 2 is over, please stay tuned for part 3. While I'm working on the V12, I'll take a video of measuring the engine parts after precision machining and before assembly. This is an indispensable task, extremely important. It helps me verify that the measurements of the machine parts are within the high standards. Everything is up to standard to prepare for assembly. There are many details that need to be measured, but in this video I will only talk about the crankshaft, because it is almost the most important part of the engine. The most important of which is the clearance measurement of the crankshaft bushing and the connecting rod bushing. These two clearances are extremely important. Too narrow is not good, too wide is not good, and I have to make sure all these measurements before assembling must be correct as in the picture I have measured for you to see. I have to replace the gasket for this engine, although it is a genuine gasket, but it does not mean that it can run as soon as it is installed. It needs to be checked and adjusted to ensure the maximum gap as I mentioned. Now let's measure. First I will measure the diameter of the shaft hole with the mouth. I will assemble these mouths similar to assembling the complete engine. The difference is that I do not have the shaft inside. I will also tighten these shaft cap bolts exactly as when I assembled them. When tightening, you must apply the wrench. The wrench is very important to help me tighten it to the correct force as required by the manufacturer. Only with lubrication can the friction of the forging be reduced, then the force of the screw body can be accurate. To measure the diameter of the machine shaft hole with this mouth accurately, I have to simulate all the operations exactly like when I assemble the machine. Tighten the force fully, according to all the steps specified in the engine manual. Like this car is both tightening the force and tightening the root. If we do it right, the measurement of this mouth hole will be accurate. These are the holes I'm talking about. Guys, these holes are also very important. The diameter of these holes will of course be a little bit larger than the diameter of the crankshaft eye. A little bit is very small, about 3 to 4% millimeters only. That is the manufacturer's standard. Similarly, I also assemble the mouth into the connecting rod. Let me measure the diameter of the large hole of the connecting rod with the mouth when fully tightened. From there I can calculate the maximum gap between the diameter of this hole and the diameter of the crankshaft. The method is exactly the same as before. To measure the diameter of this hole accurately, we have to simulate exactly the same as when we assembled the machine. From applying the grease to the hair shaft to tightening the force, we have to do it exactly as standard. To tighten the hair shaft of the connecting rod easily, we will tie the connecting rod to the milling machine table. As you can see, I tied it down tightly. When I tie it like that, I can comfortably tighten these furry babies. And of course, when tightening the furry babies, I have to tighten them exactly according to the prescribed standards. Tighten the force and tighten the base. How much force and how much base are specified in the book? I don't remember, the technician in the clip remembers. I'm just a voice employee. After tightening all these connecting rod covers, I will proceed to measure the diameter of this hole. This hole is the connecting rod hole. To measure this diameter, I use a dial gauge specifically for measuring holes. The first dial gauge is accurate to plus or minus 2 thousandths. But my required error is only plus or minus 5 thousandths. Now Mr. Keithian is using a measuring tape to measure the diameter of the roof truss. Measure the diameter of the roof truss eye and the connecting rod eye. There are two types of roof truss. Those are the roof truss eye and the connecting rod eye. I will measure so that I can record all the parameters of these diameters. Now I use the hole gauge to measure the diameter of the roof truss hole when I have it. Then you can understand it easily. When you have the diameter of the roof core hole and the diameter of the roof core eye, you take the diameter of the roof core hole minus the diameter of the roof core eye. Then it will give you the biggest gap, right? Or roughly called the play. This clearance is clearly specified in the manual. If I remember correctly, this clearance is specified from 3% to about 6% 1 mm. If this clearance is too large, the oil will flow out. It cannot be retained because the gap is too large, so it cannot lubricate. On the contrary, when this gap is too narrow, the oil cannot enter this gap to lubricate, because it is too narrow to get in, so it has to be precise. It has to follow the regulations. Then the lubrication of the oil can be guaranteed. Then this roof frame will work smoothly and last a long time, so when installing a roof it is not simple. There are many things, and this is one of them.